Hello everyone, welcome back to the channel. Today we dive into the chapter 1 of your class 10 NCERT math book real numbers. In chapter 1 there are two main algorithms. One is the Euclid algorithm and another one is the fundamental theorem of arithmetic. What this division algorithm says that if we have any dividend like A is the dividend, right? And if you want to divide with divisor B, and we are having the quotient C and remainder R, right? So we can divide any number with divisor having quotient C and remainder R. So if we divide A by B, then we are having quotient is equal to C and remainder is equal to R. This is what the Elucid's division algorithm states that. So we can write any number A which is divisor B and quotient C plus R. So how do we consider this with the real life example, right? So if you want to have the number 10 and if we have the divisor 3, so 10 divided by 3 we are having the quotient 3 and remainder 1. So how we denote in this example, 10 is equal to 3 which is a divisor, 3 which is quotient and 1 which is remainder. What is fundamental theorem of arithmetic said that any composite number, what is the composite number? There are two type of the number. One is the composite number and another one is the prime number. So what is the composite number? Composite number is the one which we can divide, right? So let's take an example that 15, right? So we can divide 15 into 5 and 3. And what is prime number? Prime number is the one which we cannot divide, like 5. We cannot divide 5 in further any other numbers, right? Now, what does the fundamental theorem of arithmetic say that any composite number can be written as the multiplication of the prime number. So let's take an example that 24, right? If we take the example 24, then we can write 24 in prime number. So if we divide 24 by 2, again by 2, again by 2, and multiply by 3, right? So if we write in prime number, then it's 2 multiply by 2, multiply by 2, multiply by 3. However, order is not important. If I write this 3 multiply by 2 multiply by 2 multiply by 2, it's the same, right? So we can express this composite number in the multiplications of the prime number. So these are the two main algorithms. We use the division algorithm in the fundamental theorem of arithmetic. Now if we come to solve the example based on these two theorems, if I want to express any number as 4 raised to n and I want to check whether if we substitute the n with any value, right, 0, 1, 2, 3, do I have any number which ends with the 0, right? So if I place n is equal to 1, then it will 4. When n is equal to 1, when n is equal to 2, then it's a 4 square which is equal to 16. So do I have any value of n which will give me the n digit or the unit digit as a 0? So if we have the unit digit as a 0, then it has to be divisible by 5, right? So if I write 10, then it has to be divisible by 5. If I write 20, then it has to be divisible by 5. So we need to find that any prime number, right? If we write the multiplication of prime number of this value, do we have 5 in this prime number or not? So 4 raised to n can be written as 2 square raised to n, which is equal to 2 raised to 2n. So it's nothing but a 2 multiply by 2 multiply by 2 up to 2n times, right? In this sequence, we don't have any 5. So if we don't have any 5 in this sequence, then we can't expect 0 in this value. So answer is no. So based on the above two fundamental theorem, we can identify whether 4 raised to n, if we place any value of the n, do we end up with the unit digit having 0, right? So answer is no. Now the third concept is that if we are having the any number a, right, and if we square them, which is a square, so any number a square, if it is divisible by p, now p is the prime number, right? Prime number. So any number a square if it divides by p, what when I say divide by p, it means that remainder should be 0. Then what does it implies that a should always be divisible by p. How we can write, right? So let's take a square, right? If you write in the sequence of the prime number, right? So let's say p, p1, p2, p3, right? A square. And again p, p1, p2, and p3, right? As p has to be there because it can be divisible by a square. Now, if I write, so this part is a and this part is again a, right? So if a square is divisible by p, then this part a has to be divisible by p as well. So what does it indicate? That if a square is divisible by p, it implies that a should always be divisible by p as well, while p is the prime number. Based on that, we can have the example of rational and irrational number. What is the rational number? Rational number is the one which we can define by ratio, right? So when I say zero point 0.6, so zero point 0.6 can be expressed by 6 by 10, which is equal to 3 by 5. So we can define zero point 0.6 as the, so it's a rational number. While irrational, we cannot define by ratio. So let's say under root 2, we cannot express under root 2 in this manner, right? So we need to find that under root 2 is rational or the irrational one. So what we will do is that, we can say if it is a rational, then it has to be defined by R by F. It is if it is a rational one, right? If it is R by S, then R and S should have some common factor. If we remove this common factor, then under root 2 can be expressed by A upon B. Now A and B are not having any common factor, right? They are co-prime. Co-prime means they don't have any mutually, I mean they are having the mutually exclusive prime number, right? Now, if this is the rational number, then I can write that A is equal to under root 2 by B. Then A square is equal to 2B. Now, A square is equal to 2B, then A square has to be divisible by 2. If A square is divisible by 2, then A has to be divisible by 2 based on the previous theorem that we observed. If A is divisible by 2, then we can write A is equal to 2 by C, right? If it is divisible by 2, then A square is equal to 4C square. If I plug the A square is equal to 4C square over here, then 4C square is equal to 2B square, right? Then B has then 2C square is equal to B square, then B square has to be divisible by 2, which applies that B has to be divisible by 2, because if B square is divisible by 2, then B has to be divisible by 2 based on the previous algorithm. If A is divisible by 2 and B is divisible by 2, then A and B are not co-prime as they are having the common factor. So if this condition fails, then we can say that under root 2 is not the rational number, it's a irrational number. That wraps up our crash course on chapter 1, real numbers. Keep practicing and remember, math is all about understanding and practice. Don't forget to like, subscribe and hit the bell icon for more such videos. In next video, we will touch base on the crash course for chapter number 2 in class 10 math.